Hello, this is Jack Jackson. In this video, we're going to talk a little bit about diagonal properties of quadrilaterals. Now, we have certain classes of quadrilaterals that we know several things about their diagonals. For example, let's take parallelograms. Parallelograms have diagonals that bisect each other. They're not necessarily the same length, but they bisect each other. Okay. Uh, on the other hand, isosceles trapezoids have diagonals that are the same length. They don't necessarily bisect each other. Interesting, okay? How about kites? Kites have an interesting property. One of them is a perpendicular bisector of the other, or at least the line containing one of them is a perpendicular bisector of the other. So if you take the one that's the major diagonal, on the one end it's where two congruent sides meet, and the other end two congruent sides meet. Then that one's the major diagonal. Extend that out to a full line. That's going to intersect the other minor diagonal, and it's going to do it right in the midpoint, and it's going to do it at a right angle perpendicular bisector. Okay? And of course, we have certain figures that combine some of these things. For example, a rhombus is both a parallelogram and a kite. It's a kite both directions. So not only do both diagonals bisect each other, they actually perpendicularly bisect each other. Okay, and then we have, let's see, how about a rectangle? And a rectangle, it's both an isosceles trapezoid and a parallelogram. So since it's a parallelogram, the diagonals bisect each other, and since it's an isosceles trapezoid, they are congruent as well. Okay, so what I want to do now is I want to flip the script here, look at the converse of some of these things. So what if we start with certain types of quadrilaterals? Look, if we talk about well, let's instead of talking about properties of the sides or angles, let's talk about the properties of the diagonals. So the first thing we can say is, do the diagonals intersect or not intersect? If they intersect, like this one, we get a convex quadrilateral. On the other hand, if they don't intersect, like this one down here, it is a concave quadrilateral. See, these do not intersect. We have this caved in portion here, and we have a quadrilateral that is concave. Okay. If the diagonals bisect each other, then it turns out it has to be a parallelogram. So that's what we call necessary and sufficient condition. That is a if and only if statement. A quadrilateral is a parallelogram if and only if the diagonals bisect each other. Well, what if just one diagonal bisects the other? Well, no, it's not necessarily either a parallelogram or a kite. It might be a kite, or it might be uh, somewhere in here, it might be a parallelogram. But it doesn't have to be. If they actually intersect, of course, it's got to be convex, but that's about all we can say about it. So what about if the line containing one diagonal is perpendicular to the other? That's certainly something that happens in a kite. Does it have to be a kite then? Well, here we have the line containing one is perpendicular to the other, as you can see here. But it is not necessarily either a kite or any other of their special kinds that we talked about. What about the line containing one diagonal is a perpendicular bisector of the other? Well, that does turn out to be a kite. You can show that if this line containing A and C, is a perpendicular bisector of BD, then this turns out to be a kite. So I'll leave that proof to you. So a quadrilateral is a kite if and only if the line containing one diagonal is a perpendicular bisector of the other. You know, here I'm just saying it has to happen for one of the diagonals being a perpendicular bisector of the other. If you have one diagonal is an angle bisector on one end, see this angle A is bisected here. Nothing really special properties or not any special things. For example, it's not necessarily a kite. However, if you have a diagonal and it's an angle bisector on both ends, then this diagonal here is an angle bisector here at A and over here at C, then this has to be a kite. So that's if and only if there. What about if the diagonals are congruent? Well, they may or may not even intersect, and even if they do, it's not necessarily an isosceles trapezoid or any kind of trapezoid at all. If you have a trapezoid with congruent diagonals, it does turn out that turns out to be an isosceles trapezoid. Okay, I'll let you try to think about if you can figure out a way to prove that. So it'll be a little bit challenging one there. Okay, so there it goes over some converses of some of the theorems that we found earlier, or properties of different types of quadrilaterals. We noticed they had certain diagonal properties, and what we're doing here is flipping that around to see if we start with certain diagonal properties, maybe a little stronger ones or a little bit weaker ones, do we still get some of these figures?